recording. There we go. What would we use to record distance, or one thing we could use to record distance? Oh, we could use a ruler. Yes? That's pretty straightforward, and we all know what a ruler is. We've been using them in elementary school, so on and so forth. So we would use a ruler. What if we are measuring temperature? What would we use? A thermometer, absolutely. Now, graduated cylinder is enriched, but you should all know what a ruler is because you've all lived in the world, right? And you should all know what a thermometer is because, again, you have all lived in the world. Yes? Yes. All right. Mass. What do we use to measure mass? A scale? Or a what do we call one of these? This is a balance, okay? Time, clock, watch. I don't even think we need to write that down. And then force. Force is a little bit weird. We're going to learn about that later. We are going to use a spring scale, and I will show that to you in just a little bit, okay? It's a spring scale. So volume is the amount of space taken up. Distance, now you have to watch out for this because there's a couple of how longs. You might want to measure how long an object is, and that would be the distance or the length. Yes? But if you want to measure how long a process takes, would you be using a ruler to measure how long? No, you'd be using a clock or a watch or whatever, okay? So just watch out for how long. It can be different in different circumstances. We're gonna skip over temperature. If you're really into like knowing actual scientific definitions of things, it is a measure of the average kinetic energy of the molecules. Anyone know what kinetic energy is? Kinetic energy, yes. Movement. It is movement energy, so it is the average movement energy. Of the particles. So the faster the particles move, the higher the temperature. And I never like mass and matter because mass is defined as something that is, mass is the quantity of matter in an object, and matter is defined as something that has mass. So I'm like, well, matter has mass, and in order to have mass, you need to be made of matter. So they're kind of, it's a circular definition, but that's what it is. How much stuff there is in stuff. Can you guys think of a force that we have used in our daily lives that we experience every single day? A force. Gravity. Gravity. Yes? If I hold up my pencil and I let it go, what's going to happen? Oh my gosh, it's going to fall. Shocker. Everything today is so difficult. Yes? All the letters are the same letter as the thing and the pen falls. Okay? So a force is a push or a pull, and gravity pulls us towards the ground. And if you wanted to, if I wanted to, I could push this balance. There's a push, there's a force. Okay? We often use symbols for quantities. Okay, and those are the ones in the brackets here. So these are our symbols. You are going to be responsible for learning these symbols, but don't worry, I've got lots of practice for you to do that. Okay? Does it matter whether you use a capital or a lowercase? Yes, very good. Now, if I was to say I want to measure the volume of some water, can you guess what unit we're using here? Like, what would I say? I've got 96 watts, milliliters. So volume is measured in liters or milliliters or some other type of liter. Okay, so volume is measured in liters, and that is the unit. So liters measures volume. And what is the symbol for volume? Is it capital or lowercase v? Capital V. Seconds measures. What does seconds measure? Seconds measures time. And the symbol for time is capital or lowercase t? Lowercase t. What does meters measure? Distance. Capital or lowercase d? Lowercase d. Meters can also be length. Now, if you're like, what the heck is that little squiggly thing here, this? That is my L. I tend to do L's like that so that they don't look like I's or ones. Okay, so that's because I grew up in the age when we learned how to write cursive. Does anyone know how to write cursive? Anyone learned? A few people? Cool. Cool. You can read the hidden code. All right. At any rate, that's a cursive L, and length is just an L. Anyone want to take a guess as to newtons? What does newtons measure? Yes? Force. And force is represented by the letter F, capital or lowercase? Capital. Okay, and now we are moving over to grams. What does grams measure? Mass. And mass is represented by the letter capital or lowercase m? Lowercase. Degrees Celsius. Temperature. And that one is indeed a capital T. Now, I will let you know, I don't get too wound up about spelling. So if spelling is not your forte, like if you're not like really awesome at spelling, as long as you get pretty close, I'm okay with it. All right? Try your best, but don't worry about it too much. Okay? Now, just like we abbreviated time to little t, distance to little d, force to capital F, we can also abbreviate our units. And a lot of them are really easy once again. How do we abbreviate seconds? S. Grams? G. And both of these are lowercase. Liters, L, it's a capital L. And newtons is a capital N. Okay. And then meters, we should all know meters. Meters is big or little m? Little m. And degrees Celsius We have to have both the degree and the Celsius. What is the symbol for degree? It's that little circle, yeah? And Celsius is a capital C. So when you say degrees Celsius, you put degrees Celsius. Be careful, it is not Celsius degrees. Okay, so degrees Celsius. Does it matter if you use a capital or lowercase for the unit abbreviations? Yes. Okay. So what we've got here on the next page is there will be a quiz on this on Friday. So that gives you 4 days, Tuesday, Wednesday, Thursday, well, 3 days, plus the morning of Friday to study for it. Okay, so you can practice, 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 practice. All right? The quiz will look just like this, but there will be different blanks. Do you see how you've got one thing in every single column or in every single row? Shall we fill this one in together? Yes? Okay. So we have a quantity symbol, capital V. What is our quantity? Volume. What is the unit for volume? Liters. And the unit abbreviation is L. Big or little? Big, big L. Also, to let you know, the enriched version of the quiz, you just won't get these things. You'll just have a blank table. And you'll have to know the 6. Yes? And just fill them in. There won't be anything filled in for you. It will just be completely blank. Yes? Yes, come and get the flash. Have I introduced you guys to the flash? I can't remember. Okay, so put it on your arm so it's away from anything. Yeah, there we go. All righty. So next we have meters. What quantity is measured in meters? Distance. We could put or length here. But you're only responsible for distance. If you don't remember length, that is okay. What is the symbol for distance? Lowercase d or L. And then finally, our unit abbreviation is, for meters, lowercase m. Okay, what do we got here? Quantity, we have volume, distance. Oh, here we are at degrees Celsius. So the unit is degrees Celsius. The reason I'm capitalizing Celsius is it's named after someone, a Swedish guy named Mr. Celsius. I'm sure his name isn't Mr. because he's Swedish, and I don't think the Swedes use Mr. But what quantity are we measuring? Temperature. And that is that big or little t? Big T. And you know what? If you have trouble remembering which one is big and which one is little, temperature and time, which word is bigger? Temperature is big. That's a big, long word. Time is a small word. So temperature, capital, big, time, small. Mass is M, little m. And what is the unit for mass? Grams. And the symbol for grams is little g. We have a small t here, and remember the word time is small, so that is time, not temperature. What's the unit of time? Seconds. There are other units of time, but seconds are the one that are most used. They are the standard scientific unit of time. Okay, so if you're finding acceleration, it's going to be in meters per second squared. If you're finding speed, velocity, it's going to be in meters per second. A joule, which is a unit of energy, is a kilogram meter squared per second squared. You don't need to know any of that, but what you do need to know is that seconds is sort of the standard unit in science for time. We will usually take our minutes and convert them into seconds before we do any calculations with them. And last but not least, what is measuring? Newtons. Force. Do you guys know the story about Sir Isaac Newton? Sir Isaac Newton sat under the apple tree, and an apple fell on his head, and he was like, oh, gravity. Okay, so Newtons are force, Sir Isaac Newton. I think that's just a story, but it's kind of a fun story. And then we have capital F. And what is the symbol for Newton? Is it a capital or a lowercase? Capital, because Newton is somebody's name, just like Celsius is somebody's name. Okay. For number 7, I'm going to just point to the ones that you should do. Okay, if you want to do the other ones, they will be enriched. So you need to do A, actually maybe I'll circle them. A, B, C, D, G, I, J. I think you can do K, L, M, N, V, and the other ones will make those black diamond ones. So if you guys want to take a few minutes you can refer to the chart on page 9, or you can just get it from your memory. You're going to say, what does the letter stand for? Let's do D, for example. D stands for distance. Is distance a quantity or is it a unit? Is it the thing you're saying, how much distance do we have? Or we're saying, I have 10 distances. It's the quantity, because you're not like, oh, this ruler is 10 distances long. That would be a unit. You would say this ruler is 100 centimeters long. Yeah, the unit is how long something is. So this would be the quantity. So take a few minutes, try those out. I'll be around to help you out if you need it. And if you finish that, you can try number 8. Okay, on the next page. By the way, sometimes I forget to record the lesson. So if you guys see this little black circle, if the little red thing isn't on, and you're like, ooh, I would like this recorded, just be like, hey, Miss Spence, I don't think you're recording. Okay? Feel free to tell me if I'm not recording. And remember, if you finish, you can work on 8 and 9 as well if you want to. Oh, yeah, Okay, you go back here and where do I have to move? There's G, it stands for France. Well, so you can go and consider yourself, is that a quantity or can I put a number in front of it? Should I say 100 grams? Yeah. If you're having trouble telling if it's a quantity or a unit, put a number in front of it and see if it makes sense. It's 100 grams, that makes sense. It's 100 masses, that doesn't make sense. If you can put a number in front of it, it's a unit. Yeah, so that would be like, yeah, does that make sense? Yeah, so like just say, okay, I'm gonna say, distance, does that make sense? So that's yeah, that's good. Yeah, yeah. Yes, it is. Wait, is that not the same as out? This one's out and that one's out. Oh. I do that exact same sort of thing all the time. No worries. Just ignore my writing here. This is so I can fix this for next year. What if I said 20 degrees Celsius? Is that something you've ever heard before? No. Okay, that's all right. That's all right. No worries. Degrees Celsius, if I have my thermometer, it's going to say 25 degrees Celsius. Great. Okay, I'm going to go grab a thermometer for you. Yes. And you put alternate units, so it would be like, volume is measured in the quantity volume is measured in the millimeters. Yeah, yeah, yeah. So that's and what am I measuring? sense. Would you say 10 distances? Is that how you would, yeah, that's quantity, that doesn't make sense, right? Right. Elevation forces. Forces sometimes go. Like on approach or well, how hard is your force? Now what if we said 10 grams? Okay. See, kind of get it a little bit. So you need to do that before I get it. Okay. Yes. Is that one height? Yes, it is. And that was weight. And that was weight. Oh, that one. Yeah. I think we can see that. It always is. So if we want to get an example, this is time. And I'll say time. Thank you, guys. I'll see you later. Maybe it's also big ones. Oh, that she's very nice. Yeah. So if you're trying to do the black diamond questions, you might want to look on page 9 because there's a chart there with all of the extra stuff. Okay. They're all different types of meters. Yeah. So yeah. Force. I don't know. To be honest. Kind of. Let's see. No other energy unit. Right. Kilograms is 20. We're actually going to look at this. Kilograms is saying like whether you are your mass. Yeah. Because you have the same amount of mass in your but you will have different weights. Weight is the force of gravity is a unit on your body. So when you get this will be different. The force will be different. Yeah, right. I'll look up and see if I'm for force, but oh, man. Exactly. Yeah. Yeah. Take the flash with you, just put them on your arm. So your homework is going to be to finish pages 21 to 23. Okay, so it'll just be giving you a little practice on filling in those tables. All right, so you can have some time to work on that now. And if you are feeling like you have run out of things to do and you're bored, I can look into getting you some enriched stuff for Unit 1. Okay, like some sort of extra things. Yes. So that's all the pages 21, 22, 23. Yeah. Oh, man. How many people feel they would be interested in getting some enriched material if I were to bring it in next day? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'm going to make like 20 or so. Okay? Yeah.